Hi everyone, Dheeraj Singh this side. So I am here to present one project which needs to be submitted for Coursera as a final project, which is for machine learning foundation for product managers. And the data which we are going to take, that is a combined cycle power plant data, and it is having one target class which is net hourly electrical energy output, the PE, and we do have four independent features, which is temperature, ambient pressure, and relative humidity and exhaust volume. So let's have a look about the code, what we have to accomplish here. So basically this is a regression analysis, and in the first stage I'm going to download the required libraries like pandas and numpy and matrix and matplotlib and seaborn just for data visualization, and we need some kind of specific libraries for model building and to evaluate my model. So in the first time, at the first step, I have just loaded my data, and this is data looks like. So it seems that okay, we have a lot of continuous variable, and this is my the target class. And the data shape, if you can look at data dimension, we have 9568. This is my observation, and with the 5 columns, and we don't have any kind of null values here. And the next portion, we did little bit EDA portion here. The second part is that heat map analysis, which is just telling to us that okay, do we have any kind of significant multicollinearity or not. And by looking at this heat map, we can say that we don't have the high amount of multicollinearity, but there are some variables are related. As example, if you can look at here, AT and the V, this is ambient temperature and volume, that is the 84% correlated, right? And other, if you can look at here, RH and P, this is a little bit highly not highly normal correlated, and the same thing we can look at here in pair plot as well, right? And then I'm just going to take different machine learning models like regression model, linear regression model, and decision tree and random forest models. I'm going to experiment with that. And here what I'm trying to do here, I'm just doing little bit normal feature selections. As example, in x2 it contains just the two variables, independent variables, and the third feature selection I'm just going to combine ATV and AP, which is three features, and the final I'm going to take the four features here, which is ATV, RH and AP, and my target variable would be my Y, which is PE. Let's have a look about here linear regression model. This is simple. Here we have done the train test split about my data. So the train, like X train and Y train, that would be needed for your model training, and X test, Y test is needed for the model evaluation. Here we have taken just 80-20 the split criteria, and here I'm just building a linear regression model, and here I'm just fitting my X train, Y train, and once it is fitted, I'm just simply doing prediction, which has been saved as a ypred, and then I'm just passing out here in the mean square error, where we have actual data points and the model predicted data points. So based on that, we are getting here RMSE value 5.22, R square value 0.90. So model is pretty good here. Then we are experimenting with three more features. So basically we have combined the three features here, and then here accordingly we are getting RMSE little bit low compared to the previous one, which is 4.7, and R square value little bit improved from the previous experiment, right, which is 0.92. And the same way we have taken here again all the independent features all together, and we have built a model, and we are getting here the R square value, which is closer to 0.93, and this is a little bit improved, right? So it says that okay, if we are improving the model like the features, so it is improving the results. Then I built a decision tree regression model, and here we are just calling here DT regressor, like decision tree regressor model, and we are just feeding X train, Y train data, and here we can look at RMSE value, which is 6.77, R square value we are getting 0.84, and then we have selected here the three features all together, and with the three features I'm getting here RMSE value 4.39 and R square value which is 0.93, and that's a little this is, if you can look at, this is closer to 9% improvement, right? And then we have just taken all the again four features, and then we have looked at here that is not improved results, because in the decision tree when we have just taken the two features, that was little bit improved, but with the four features it is not improving. So let's experiment with the random forest regression model. So this is one concept of the bagging model, and this is extension of decision trees. So we are assuming that based on the parallel model building, and here we are building multiple decision trees internal, so probably it can perform well enough compared to a decision tree. So let's have a look here. So when we have just taken here x2 data, basically we are just taking the two independent features, and when we are calling here random regression model, we are fitting my data here x train y train, and after that we are just selecting here mean square error and r square value, and we are getting here 5.07 and r square value which is 0.191. so r square value nothing but this is simple a how my linear line which is y is equal to mx p how it is fitted, right? So if you can look at then the next experiment with the three features, so we are going to select here the three independent features, and we are just taking 80-20 split, and again I'm just fitting my model with x and y train, and here if I can compare with the RMSE and R square value, this is a little bit improved from the previous experiment, right? So and with all the independent features altogether, the four features, and RMSE value is 3.21 and R square value is 0.96. So if you can compare with all the experiment what we have seen so far with the linear regression model and your decision tree model and random forest model, and also we have experimented with this kind of at the one level we have just taken the two features, then three features, and four features, we have seen that random forest model is performing very good. And if you can look at R square value is 0.96 and RMC value is 3.21. So now if we can do some kind of cross validation approach for the random forest, so let's have a look about how the model is consistent enough. So if you can look at cross validation score with just 5 folds here, like for five iteration. So why I have selected here x4, because we have seen earlier that okay, when we have selected just four features, four independent variables, models was like random forest was performing very well. And here with the cross validation here, if you can look at in the first iteration I'm getting 0.96, second iteration I'm getting 0.95. So this is basically accuracies, and the third iteration 0.96, and so on and so forth. So if you can look at here, the model is performing very consistent, like model is very consistent in terms of the accuracy. And now if you can look at here the predictions with the help of random forest model with all the features, and here we are getting here x and y axis. So we can look at this is having very highly positively correlated, so it can say that if we are having any kind of x values, so based on that easily we can predict the y values. So this is a very simple approach just to submit a Coursera project. So thank you so much, I hope you like it.